Welcome back. Today we're going to be working on the last video of 8.3. What we're going to be working on is just identifying the important parts of a parabola. So remember, a parabola is just a U-shaped graph. It's a quadratic. We're going to go through some vocabulary words first. So let's go ahead and first start with this point right here. Did you notice this point lies on the y-axis? So this important part of the parabola will be called the y-intercept. Oops. Now to find the y-intercept, it's always, remember we sub in x for 0 to find the y. But if you remember, a quadratic in standard form will be written as ax squared plus bx plus c. It's always going to be 0, comma, c. All right, let's go down to this point right here. Remember, this is the lowest point of the parabola, so it's our minimum. This important part is called a vertex. Now to get the vertex, remember it's an ordered pair, so something, comma, something. To get the x-coordinate, it's a formula, it's opposite of b over 2a. And then to find the y-coordinate, you're just going to sub your x value into your equation to find y. If you notice, this dotted line cuts my parabola directly in half. That is called the axis of symmetry. And it's actually, in order to find the axis of symmetry, it's always the x-coordinate of the vertex. And since it's an equation of a vertical line, it's x equals. And to figure out, again, we use the same formula. It's opposite b over 2 times a. And lastly, this point right here lies on the x-axis, so this will be the x-intercept. Now we either substitute 0 in now for y, or we can just look to find it on the graph. Now, what we're going to be working on today is if we know the x-intercepts, those are also called the solutions. So also called solutions. So here my x-intercept would be 1, so 5, 6, 7, 8, 9. It'd be 9, comma 0. If I specifically asked you for the solution, which I will later in the notes, you would write x equals 9. So the intercept will be the point on the x-axis, and the solution would just be x equals that x-coordinate. All right, let's go ahead and go through. All right, so remember my vertex is the lowest point on my graph. My vertex here would be -1, comma -4. Remember my axis of symmetry is is the vertical line that splits my parabola directly in half. It's x equals, and then it's always that -1. Sorry, let me fix that. It's x equals because it's an equation of a vertical line. Remember that vertical line cuts the x-axis, and it always is this. The x-coordinates are always the same. The y-intercept is the point on the y-axis. The point on the y-axis is 0, comma -3. And here, if you notice, I have two x-intercepts. My graph crosses the x-axis both at -3, 0 and 1, 0. So I put -3, 0 first. The order does not matter. And then at 1, 0. Since I have two x-intercepts, I will have two solutions. Remember, solutions are like solving for x. X is equal to, first one is -3, second one is 1. Okay, let's go ahead and do number 3. All right, so again, my vertex, remember, is the lowest or highest point on my graph, and that is 3, comma 0. The axis of symmetry is the equation of that vertical line that cuts my parabola directly in half. Again, it always goes through the vertex. That's why it's x equals 3. My y-intercept is the point on the y-axis, and that looks like it is 0, comma 9. Here I only have one x-intercept, so it's going to be 3, comma 0. It's actually the vertex. Since I have one x-intercept, I'm only going to have one solution, and that solution is going to be x equals 3. All right, let's move on to 4. All right, so my vertex right here is negative 1, 4. The axis of symmetry will be x equals negative 1. My y-intercept is 0, comma 5. Don't forget you have to have parentheses here. Now, do you notice if I have any x-intercepts? Here's my x-axis. Does it cross? Or does it intercept at all? Intersect at all? No, so I have none. So if I have no x-intercepts, I have no real solutions. All right, let's go ahead and jump up to 3. Again, let's go ahead and go through my vertex, which is right here. My vertex is negative 2, comma 4, so my axis of symmetry will be x equals negative 2. My y-intercept looks to be down here, which is 0, negative 4. Now, do you notice that all the previous 3 questions that we've done, the x-intercepts have either been none or have been nice ordered pairs, but they don't always have to be. So if you notice, it crosses the x-intercept, the x-axis here, but they're just not at not nice ordered pairs. So when that happens, we're just going to guess. There'll be a way in the second part of this chapter that you'll find the exact solutions. So let's say it's like negative 3.3, comma 0. Again, I'm just guessing. And let's do negative 0.7, comma 0. Again, we are just estimating. So then if I have 2 x-intercepts, I have 2 solutions. That's x equals negative 3.3, comma negative 0.7. Again, adding that 0 in front of the decimal does not do anything. All right, let's go ahead and go to the back side. Now we've been talking about the x-intercepts, and the x-intercepts determine how many solutions you have. So here it says match the quadratic equation with the number of real solutions. Remember, we are looking for the x-intercepts to figure out how many solutions I have. So here's the x-axis. Does my quadratic even intersect the x-axis? No, so graph A has no real solutions. All right, let's look at graph B. Here's my x-axis. If you notice, my graph intersects the x-axis once, so graph B has one real solution. And what is that solution? It's x equals negative 2. Now remember, if I ask for the x-intercept, remember that's the point, that's the ordered pair, that would be negative 2, comma 0. All right, and let's go to graph C again. We look at the x-axis. If you notice, I intersect the x-axis twice. So how many solutions will it have? It will have 2 real solutions. And those solutions are x equals 1 and 3. All right, let's go ahead and do a quick application question, and then you can try one on your own. All right, so Zach is getting ready for his upcoming baseball season. He needs to practice catching pop-ups. If you don't know what a pop-up is, it's you just throw the baseball as high as you can, and then it comes right back down. The graph below shows the trajectory path of the baseball when his friend throws it as high as he can. So his friend's over here, he throws the baseball, he gets all the way up here, and it comes back to the ground. Let x represent the time, so this is time, and y represents the height. What is the baseball's maximum height? Well, the baseball hits its max height here. So this ordered pair would be 5, comma 20. But if you notice, I'm asking for the height, so that's the y coordinate. So that would be 20 feet. I should have given you units. Sorry, it's feet. And then what time does a baseball reach its maximum height? Well, that's the y coordinate, so there'd be 5 seconds. It would be here. So again, the vertex is 5, comma 20, where 5 is the time and 20 is the height. So since part A, I wanted the height, I want the y coordinate, and since I'm asking what time, I want the x coordinate. And then estimate the time when the baseball hits the ground. Well, the baseball is going to hit the ground right about here. Remember, that's my x-intercept, but I don't want the point. I just want to know when it hits the ground. I'm going to use a round that's approximate. Let's say 9 point, what do you think, 5 seconds. And then later in this unit, we'll be able to find the exact time it hits the ground. All right, go ahead and pause the video to complete the last question. When you're ready to check your answers, press play. All right, so here is my diver standing at the high board. Remember, when you're on a diving board, you jump up and then you come all the way down, and that's when right here you're hitting the pool. So on the ground, that's where the pool is. What is the max height? Well, the max height will be the y coordinate. It's about 14 feet. What time does the diver reach the max height? Remember, that's the x coordinate of the vertex. That'd be 4 seconds. And the time that the diver reaches the pool, the diver is going to reach the pool around here. I said around 9.2. Acceptable 9.1 or 9.2 or 9.3. That would also be acceptable. All right, go ahead and stop the video to complete your homework.